Thank you. Okay, so good afternoon. Indeed, my name is Evangelos KEMENTZETZIDIS. I'm an assistant professor at TU Delft, and I will talk about the design and analysis of cyclic monopile behavior in cohesive clay soils. Before I start my presentation, I would like to thank the co-authors of this publication. So, good monopile design requires that we have a good grasp of lateral capacity of the foundation, cyclic stiffness, and tilt accumulation, all within the context of a lifetime of operations. When we want to identify these properties in cohesive soils, first thing we need to do is we need to understand the complexity of the geomaterial, but then establish also a solid link between the geomaterial behavior and the cyclic monopile response. Complexities that we face when we're working with cohesive clay soils over consolidated ones have to do with cyclic softening, rate-dependent response, post-cyclic loading reconsolidation effects, and pile-soil gapping effects manifesting between the soil and the monopile. On the right, you can see evidence of the formation traits, both in the laboratory level, but also on the pile-soil level. And for more information about such complexities, I would invite you to read our accompanying ISFOG publication. So, to shed light into these challenges and produce a model able to enable us to do simulation of cyclic monopile response in cohesive soils, in 2024 we launched at TU Delft with the support of research and industry partners, the so-called MIDAS Clay project, a kind of follow-up of the MIDAS project, which had a similar scope but in sandy soils. The recipe is simple. We're doing laboratory testing to understand the cyclic geomaterial behavior, in this case clay, and then we're doing centrifuge testing and 3D finite element analysis to understand the response of monopiles in cohesive soils. Then the idea is that by leveraging information coming from these two sources, we would be able to produce a 1D cyclic soil reaction model to support monopile analysis in cohesive soils. The project is at a very early stage, so not a lot of information to show yet, but we have done already some centrifuge experiments, and here you can see some pictures from sample preparation to installation of monopiles and loading of the setup to the Deltares geocentrifuge. Just a glimpse on very early test results that demonstrate these critical effects and how they manifest on the global monopile behavior. On the left, we have force displacement response of a single monopile dimension. On the black line, you can see the monotonic response. On the blue line, you can see the kind of equivalent rate cyclic response, and you see a very good agreement. And with the red line, we can see when we reduce the frequency of the cyclic loads from 0.5 Hz to 0.1, we see the effect that this has on the cyclic displacement behavior of our foundation. In the middle, we see evidence of pile-soil gapping. And on the right, we see some trends of displacement and pore water pressure time histories from some selected centrifuge tests. Here are the references that I used for that picture, including the complexities that we would expect for monopiles in clay. And lastly, I would like to thank friends and colleagues that support this research from TU Delft, Deltares, and NGI, and also research partners. So thank you very much for your attention. And if you would like to ask questions about the MIDAS Clay project or perhaps join our initiative, please don't hesitate to contact me. So thank you very much.